Good afternoon to all of you, and good morning, good evening, wherever you are. So today we'll be just seeing the application of QGIS for getting the details, like how we can use the QGIS for different map making processes. So that's what we will be seeing it today. So in this session, basically this whole session is only live demonstrations. So in this case, we'll just see the few of the concepts which we've discussed, like how the classification schemes is being applied and being used. So we'll see a few demonstration of all those and try to understand from the user point of view who will be making use of your map, how they can interpret or misinterpret your informations if you are going to represent them in that form. So this is just a vector file which is shown on your screen. So in this case, as you can see that these vector files are nothing but data sets which is having an attribute as well. And in this case, as you can see, there are few attributes which we can have a look, like these. So these are the attributes. So it's just like having a few ward number, the corresponding area, and then a few attributes like density per square kilometers and so on. So those are the different informations which is available as an attribute form. And what we'll just try to do is like how these attribute data can be represented in QGIS for generating a different maps. And we'll also look into the kind of classifications, their impact, and so. So we'll quickly go through the properties. So just go to a properties sections. There, as you can see, the right click and go to properties sections, and under that there's a symbologies cases are there. So like in this case, we are having a different symbologies options. So under that symbology options, you are having a different way of interpreting your data sets. So do you want to show all of them using a single color? So by default, your polygon is having a single color. So it means like all the polygons are filled with a single symbol, and the color is actually a red one. So that's what we are seeing it in this. So what we'll do is, instead of this, we'll just try to do an categorizations based on classification. So let's do a first categorizations options which we will choose. So under the categorizations or the categories of the attributes, so we have to choose the different columns. So in this case, we are having a multiple columns available to us. So in this case, what I'm going to do is I'm just going to select a text columns. As you can see, this is basically showing an ABC. So that means that this value is actually a string. The other, I think you're already aware of, like the points basically represents the cases of where the fractional points are there. In other cases, if you see numerical values, so these are the numerical or integers values which is being given here. So first, we'll just try to categorize the value of population density. So let's select that column. And then what we'll do is we'll just try to do a... Okay, so we'll just resume. So welcome back. The system got stuck. So let's now start, we'll again restarting the whole process. So once we have the data sets, vector data sets available with us, so this is just an example of that vector data sets. So under the property sections, you have different options of symbology. So like at the beginning, you'll just be able seeing that by default, any vector files will be given especially a single symbols. So if it is a polygon, it will be a fill. Otherwise, the corresponding line color options will be there. So now these data sets is actually in polygon form. So you're seeing this is different polygons are there. So what we'll do is we'll try to see the different attributes which is available to these polygons. So over here, there are different attributes like ward number, area, and there are different FIDs, and then other details are there. So we'll be seeing, so we see in this case, there are different type of data types which is available to us. Few of them is actually in term of name. So like this is the ward name, which is a complete categorical data only to differentiate. Then we are having a few integer values, like these are the few populations. Then there are area values, which is nothing but a kind of float values which is available to us. So there are different kind of values which is available to us. So at the end also we are seeing that there are an ordinal attribute data is also available, especially the categorical ordinal data sets is also available to us. So we'll see that how these data sets we can represent using the QGIS. So let's say first start it with a simple case where we will be selecting the ordinal attribute data. So in this case, it's category options. And as we have observed in our attribute data, the ordinal attribute data is nothing but a population popped in. As you can see, this is also having, it is also showing that it's in the string 254. So it means like this is a string characters. So this is nothing but a kind of categorical data which we are having. And this is also given as a symbol as ABC. So I'll select that one. And then I'll simply add classify. So when I click on the classify buttons, then we will see that there are large number, the different values, the unique values which is available to us is getting displayed. And the option given to this is as a simply the random colors. So in this case, each of those categorical data are random colors, which has been provided to us. So if you apply this, in this case, we are seeing the case where there are different colors has been assigned to these polygon. So if somebody is given these informations about these polygons and he or she will, let's say that you just give these pictures and tell anyone that what do you see or what you can interpret from this particular informations which is being shown to you. So probably the users will look into that and they will say, okay, this is basically different colors as being provided to us. And these different colors are being provided to us. And in this case, there are few colors is being assigned and there are 5 colors are being seen. So at max, you can visualize that there are few colors which is grouped together like this and so on. But it's very difficult to interpret what exactly these color means unless and until you provide some kind of additional informations. So if you provide an additional information over here, which is nothing but a kind of the legends, like which is being made available to you. So if these legends are made available, then probably the users or the end users will be able to decode. So as we can see, the purple color is basically showing an high density population density area. So this can be see, okay, so these are the high population densities area is there. Then you're having a green color, basically the dark green color, which you see at the center. So it is basically showing and giving you the informations that these are the very high density. So it's high density, very high density, and so on. So you see that there are different options user can interpret. So to fully extract the information from this, the user need to spend a lot of time, or your map readers needs to spend a lot of time. He or she needs to interpret, look into a lookup tables, form a mental pictures, and then look for all these information. And probably if he or she will go back and try to recollect what were the information, so it will be very difficult to recollect it. And in this case, basically these colors, the random colors, basically is showing, and is at max will be able to differentiate that there are different polygons. That kind of informations will be user will be able to interpret. Now, same informations, what we'll do is we'll simply use a case where we'll change the values as per our understanding. So what it means is that we'll just put it into proper order. So this is very low. Then we will put it into low options. So this is very low. Then you're having a low options. Then we will put it medium. Then we'll put it high and very high. So this I'll just remove it. So these are the 5 different categories which is available to us. So low, very low, medium, high, and then very high. So this is basically an order which we are having. We are having a very low, low, medium, high, and very high. So these are the 5 different densities. According to some categorizations, the data collector has made it. Now what will we do is, instead of these using a random colors, we'll use basically the color ramp, and which is basically increasing the intensity of the color from white to a dark green. So if you apply this, and if I just display this same information again, now if somebody tells me that, okay, what is the informations which we can get it from this whole layer. So in this case, we are seeing that there is a change of intensity of the colors. So if somebody wants to interpret it, so they will definitely will be able to find out, okay, there is a kind of different polygons of different colors. And since there is an incremental increase of the color intensity, so he or she will also be able to basically find out the relationship which is found among the group. So it means from the lighter to darker tone, if the user is trying to interpret, so he or she can easily make out that the informations which is present over here is probably also are interrelated. And this is basically the additional advantages which you are getting it in terms of color potentials, color ramp, whenever we are using it. So in this case, you see that the earlier also we were using colors, but those colors were actually a random color. But now we have assigned those colored as per the order or ordinality of your informations. So if you interpret these data sets, so even if the legend is not being provided to the end user, the person can make out, yeah, there is some values which is changing, and probably there is a value which is at the center is very high and value at the periphery is low. And he or she can easily interpret, okay, there are large amount of clusters, center cluster with dark color tones, and it is surrounded by a lesser tone color. And accordingly, the lot of other informations can be extracted. So this is an extra advantages which you are getting when you use properly the color tables instead of random color. So this is taking your data sets where ordinality of your data set is also being passed on to the end users by applying a simple color ramp, and he or she can also will be able to look for or try can interpret the basically the interrelationship between different groups. And the this can also the legend can also provide these additional informations, and that interpretations can be continued. So this is the case where we are having an ordinal categorical data. But now let's see that, and this data has been prepared and created based on some classification. So somebody has done some kind of analysis, and based on that, he or she thinks that these are the way the intensity or classification has to be done. And based on that, the ordinality of the classification has been carried out. Now, let's say that in the cases where you are not having any values, but rather than you would like to categorize based on cases where how does a particular column and values is being given. So let's say that that was the population density which was being interpreted and provided by the some analyst. Now we'll just take another column. So this is also giving density per square kilometers, and there we will see the histogram of all these values. So as you can see that there are an increasing trend of the values, then it goes in between. So it means like it is showing a kind of 2 to 3 different models or category of a grouping of the data sets which we can see over here. So almost all these forms on a same class. If I look for normal distributions, the other part or these areas will be basically mixing of these two classes and so on. So it seems like if we are going to look into the histogram of this particular distributions, then what we can do is we can create some kind of grouping where subgroups can also be identified. So in QGIS, if you want to increase the bins, you can increase and see that how the different histogram is changing. So that basically will help us to interpret what should be the ranges of the values in the group and so on. So in this case, as you see that the values is being put in, you can increase or decrease the options, the corresponding mean values, standard deviations, and all. So this is basically overall data sets. There are on the right side, there's a very large tail, which is we are having it. And mean is exactly not matching with the median value. So it means like we have to look for a way where classes should be put in such a way that these means should at least match with the median values to justify the normal distributions. So once we look into these data sets, so we can decide how many classes we can look for and so on. That's one way of doing it. Another one is that you can directly go in and apply the classifications algorithms. So one way is that you simply take the values, like in this case we are having the values available to us, and the color ramp will be applied. And as we can see that in this case all these values are quite unique values. So in this case we are having colors where each of those polygons, the numerical values is being represented as a decreasing or increasing trend of color ramp. So in this case, the increasing trend is being shown over here. Now let's say that we categorize it into different classes. So for that, what we will do is we'll apply the classifications schemes. So let's I'll take up the questions at the end. So whoever is having the questions, please keep it on hold, and we'll taking those questions at later stage. Okay, so I'll just repeat that the earlier category of classifications, which was based on the categorical data, and that categorical data was population density. So as you can see in this case, these were the classes or levels which were available to us, and these were used. Now, how somebody has arrived based on this, some analysis has been carried out, and based on that it's being done. So this is basically to show that if your data set is in categorical in natures, so that can be used for the classifications. That can be used for different classifications. You can directly use it if your ordinality is there. If you are going to use the numerical values, like in this case, we are using a density square per square kilometers. So now this is basically a numerical values which we are having. And this data set needs to be classified in or a grouping has to be carried out. So to look into that the data set, first is that you simply assign all these values separately and try to interpret it. So in this case, we are seeing that all the individual polygons, whatever the individual polygons are there, so those individual polygons are having multiple colors. Like in this case, this particular polygon, which is having a values of, in this case, it's around 4284. So this 4284 is for this particular polygon. Similarly, this can have a separate polygon, but all these color has been assigned based on the color ramp. So like in this case, you're seeing color ramp will have a least values. So in this case, it will start it from 1163 and it will end it at the max value. So this whole range will be used 39845. And there is a linear scale which has been assigned to this. And based on that, the classifications will be carried out. Now, let's say that what are the different ways of classifying the data set other than these. So in that case, we can create a few rules over here as well. So you can say that all these colors with a specific values would have one color or some other color that can also be used for yes, these values are basically population people per kilometer square. So it's a kilometer square, not per kilometer. So that's basically a values which is being shown in this case. Now there's a graduated symbol which we are seeing over here, and the classifications which you want to carry out. So I'll just again select the same density per square kilometer column. Now over here you are having a lot of different options. So one is the equal quantile, equal interval, and so on. So these are the few techniques which we have discussed yesterday's. So let's say that we are going for an equal count. So it means like the whole data will be divided into equal parts. So 20%, 50%, depending upon the classes. So by default, we are taking 5 classes over here. So in this case, we are having 5 values. So accordingly, 5 equal interval will be created. It means like there will be 5 elements, 5 classes, total 60 different words are there. So in each class, you will be having 12 elements. So if I classify based on that, so accordingly your entries, so within the first class interval means that the lowest 20 class values are from 1164 to 4992. So this is basically the lowest values or the first class which we are getting. So once we'll have that and we'll apply it. So in this case, we are seeing that the outer boundary is having a lowest values. So it means like 12 classes, which is the lowest values, are actually is being shown this white color. Next 12, so it means like the reddish, light reddish color, which you are seeing it over here. So these are basically the next 20% of the classes. So 20% of the 60 is 12 classes. So there are total another 12 classes which is having a separate color. So in this case, the whole color ramp or the color symbols, in this case we are having 5 different colors which we are having over here, and all of these class intervals going to contain the equal number of classes. So in this case, first 12, next 12, and so on. So this is what we are seeing in this case. The advantage of this scheme, as I was telling, this classification is good when your histogram or the cumulative histogram, when it is showing a kind of straight line, you'll be having a distribution like this, or in the cases where you expect your data set to be a completely or almost same values in all the cases, so in all the polygons. So in that case, we can have basically percentile based linear classifications we can go for. Now what we'll do is we'll make changes into it. So I just want to see what is the impact. So instead of having a quantile classifications, now we'll go for equal interval. So equal interval means dividing the whole range into 5 different parts. So starting range is 1163 and ending values is 39485. And then what we do is we break it into 5 different parts, and accordingly we see the range is being divided into equal interval, and this is what the equal interval is. The approach is called. I'll just say that if you have any queries, you can just refer back to the yesterday's lectures again. So now I'll just apply it. So in this case, now you see that if I go for an equal interval cases, then what has happened is that the large amount of the large areas or the large number of polygons which we are seeing over here is having or falling into a same class. So it means like the number of classes or the color tables utilization is no longer 5. So if you look into that, so probably as an if you want to see or if you would like to interpret this whole thing, you'll also see that even though we are assigning the 5 different classes, 5 different classes and each of different color, but if you try to just look into and have a glance, so you'll see that almost only 4 colors is being used. So by visually it looks like okay, 4 colors is being used, and if you give it to some persons to just interpret how many clusters they can see, so probably he or she will say 3 or 4 clusters, provided that he or she also interprets this as a cluster. Otherwise, the white color, the dark red, and in between you're having a median values. So this is the drawback, that when you use the equal interval, so in that case what may happen is there is in some cases the values will fall into only in a very large number of value will fall into a specific classes. So like in this case, as you can see over here, the large number of polygons which was there while using the equal interval. So over here the values in this case there are total 6 number of polygon which is falling in the first category of the classes or the total range. Let me increase the value. So this is total values is 3 plus 4 plus 7 plus 10. So there are a very large number of polygons. If you add all the cumulative values of these cases, then in this case you'll see that very large number of polygon is only falling in the first group. In the second group, you're having a very lesser number of classes compared to one. Like in the case of last group, as you can see over here, so there are only 4 different polygons which is falling under this group. So in this case, as you can see, polygon this 1, 2, 3, and 4. Total 4 polygons only is having the darker tone, which we are trying to show it over here. So it will be like this. It's very difficult to interpret or differentiate between these 2 colors, but still, if you could do it yourself, you'll be able to see that there are only 4 classes which is falling into under these categories. So the equal interval in this case, what is happening is the whole color tables is not being utilized. Some of the classes will be heavily loaded, and it is not proper way of classifying the current data sets, whatever we are having it. So now let's apply some other cases. So let's take an example of natural breaks. So in case of natural break, what happens is that your histograms are being broken at a places where the cumulative frequency changes suddenly. So it means like, or there will be a very large amount of variations in the values. So these are the basically the boundaries which is being done, or which is according to that the classification has been carried out. And this natural break basically gives you a cases where the grouping of the values will be done based on the histogram clusters. It's a nearby histogram clusters which we are seeing it in this case. So when you apply these natural breaks values, then what we see is that the corresponding spatial differences or the representation of these values is also visible on the screen. And if you see it, that the way the histogram grouping and classification is being done, this there is also a spatial clustering is also visible on the map as well. So if you see, there are a lot of other things automatically is being highlighted over here. So if somebody looks into these cases, so there will be he or she can say, okay, there are one clusters at this place, another clusters at the another places like this. So it means like there are a larger cluster and there's a smaller cluster which is also being displayed over here. So if you see that this is also giving based on histogram and spatial cluster, both is there. So that shows a kind of phenomenon where the study area is having two separate cluster centers. One cluster center is quite, which is having a larger number of polygons, and another cluster centers which is nearby grouped by these values is the second cluster centers. Then there are also, so why is it so? Why is it happening? And what is the meaning of these? We can interpret based on the understanding of the areas. Like, why do we have two different clusters in this case? So this is just an example where the city core is there. So this is the first city core, and there is also an added cluster center, or the city growth has happened after some years. The another city center has also came into picture. So these are basically due to the road constructions and so on. So accordingly, we see that the two cluster centers has been formed, and this is smaller cluster. So that also indicates, if you study from the or if you look into the city cycle. So if you're having a larger number of clusters center and the ward values is large, so it means this basically represents the old city. This is a newer part of the city which might have developed later stage, but now has an potential of growing further and so on. So natural breaks basically, the classifications basically helps us to identify such subgrouping. So in subgrouping in your data sets along with the spatial clusters as well. So this is just an example where natural groups or natural break classifications can help us to identify the subgroups in your data set. So this is one group. So few of the polygon around it having a one group, and there are another polygons which is having another group. Now, there might be a lot of other questions, I think, which one of them, which generally we say, okay, if this is the clusters, why there is our different places just nearby to this high density area, there is a sudden very low density classification data sets or classification area is there. So why suddenly the highest values is coming to a lower values. So if you study if you overlay this whole polygon with satellite imagery and all, you'll come to know that there's a very large green patches over here. So this is a kind of restricted governmental areas. So there's no development was being allowed in these areas, and it is having a very large green cover available over here. So due to that, these two wards was not having a very high population density. Otherwise, if there would not have been any control on these areas like the government lands, then there would have also been cases where these two wards would also have grown. So that kind of interpretation at later stage, which we can do on interpretations at later stage. So this is basically to show you that how the classifications, different classifications schemes, when you select, so they can highlight some specific conditions, and those specific conditions can be further interpreted and analyze why is it so, and that can give a large amount of extra informations and so on. Then there's another classifications which is called pretty break. So let's change it. So this is basically giving the values almost in term of numbers, especially the some psychological numbers like 10,000, 20,000, and so on. So all these kind of pretty break, almost linear fashions scheme is being used. So this is more or less similar to the linear classifications or the equal interval classifications, but only difference is that instead of having numbers selected based on the data set, you decide the interval with numbers, specific numbers. So those numbers may be 10,000, 20,000, and so on. So those are the standard numbers which is being used. Then there's also an options to the fifth classifications, which now we will see, is basically the standard deviation based. So in this case, standard deviation based. So over here, we'll create a few classes. Okay, so let's create a few classes. So this is basically giving you the mean values, the corresponding to the first standard deviations. So that's basically a darker color. So this is the mean values of all data sets, first standard deviation, second standard deviation. So second standard deviation and first standard deviations basically shows that how is the, so all the values, first standard deviation on the left hand side will show the lowest values, and on the right hand side you are having a highest value. So these lowest and highest values are at the first standard deviation apart. So this basically tells that there is a kind of large disparity or the differences between the on the left and the right hand sides. That's what is being depicted over here. So in this case, the representation is being put in. So let me also change a few color options to some other color. A bit more. Yeah, so if I use this color, so in this case, you're seeing that the first standard deviations values, so these are the highest values, and the purple color are the lowest values. So all the highest values on the right hand side of the data sets are located at the centers, and on the stream values are almost located at the periphery of the city. And in between also we are seeing a few places where the lowest values is there. Now why this disparity? Why suddenly there is an very large values in one ward, and in another ward there's a very less values, and these two are quite extreme values in terms of standard deviations. So this is on the positive side of or the right side of the mean, and this is the left side of the mean at two standard deviations. So this disparity, why is it so? So if you look into that, the reason I already explained to you that these were the fully green covered government controlled areas. So no development was allowed in these lands, and that's why this disparity has been there. So this is basically also shows the influence of some policies, how it is also affecting the different city growth. So all the areas which we see in the centers where sudden disparities being observed at the boundaries, so there you can expect that there has to be some kind of physical or in terms of city, it has to have some kind of physical barrier, or there may be some kind of policy related barrier which is causing a kind of disparity. So the standard deviation based approach basically gives us an options to find out in our data sets how the lower and higher values are linked, what is the differences if suddenly higher and lower values are co-located or nearby values, then there has to be some kind of reason for that. Otherwise, generally we expect in spatial clustering systems that as you move away from the center of the clusters, the whole data has to be distributed in a equal manner. So if there is no distribution like that and sudden disparity is there, then there has to be some reason for that. So in this case, a very well known disparity can be observed. So this basically shows the impact of how does the classifications of your data sets can help us to highlight the specific objectives. So if you want to show disparity, then in those cases you bring out the standard deviations. If you want to find out natural grouping of your data sets, then in those cases you can go for equal interval classification schemes. If you want to bring out that how the data set is changing, or if you're having some specific condition like PT breaks and so on, that can also be done. In fact, in some cases we can also add some additional columns and do some geometrical mean, harmonic mean, and so on. So in those cases, the histogram will be the basic features where the study has to be carried out. And once that once it's being done, then based on that, the corresponding classification schemes can be chosen. So once we have these, so let me put slightly proper color. So just go with red color. Okay. These natural breaks. So once we have done a classification which we wanted to represent and so on is being done by using the data sets, then there are an options to convert and do an output map productions. So for that, what we can do is we can go into layout managers, give if you're having some options to already available layout like where should be your main values, where should be your legend, and so on, that can be stored in a layout manager. So if it is not there, then what we can do is we can create a new one. So over here we can give it to that. So I'll just name it as a test. So this is basically giving you the complete layout. So these layout, we can make changes in settings like what should be the paper size and so on. So those modifications which we can make it, so you can explore it further. Quickly, I'll just show that whatever features which we have and how much space which we want to represent. If you put it like this, then correspondingly in your area or the whatever feature which you have selected will directly be made visible to you. So once you are having this main features which you want to show is being represented in the interface, then you can do, or you can put other map elements like there are items, add item groups. So in this case, you're having labels, legends. Like in this case, I can add a few legends like that. So if you want to make some modifications, that later on we can make it. We can also add a few arrows. So there are different map elements which can be added in this case, whichever way you feel you can explore it and make use of it. Okay, so do this again. So this is basically an arrow. There are different options of arrow as well. So if you're having some vector file that can also be added. So you can just try out different options which is available to you. So you can try out the different options for that. Then if you want to add some titles, that you can add it as a label. So here label where you want to put it, your text and so on, that you can do it. And then if you want to make some changes, fonts, so those are the options which you can make use of it. So in this case, I can put names like so that can be added. So this is basically the way you can put the text. If you want to make some changes in other appearance, no, you don't want this font, you want some other font and so on. So those are the few things which you can make few changes to that. So once you are happy with your layout, in fact, there's also an options to add other elements as well. Like if you want to put some logo or some other thing as per your organization, so you can put it as add pictures options that can also be added. And if you want to have, so once you put it all these map elements, then what you can do is at the end, you can export it in the form of image or PDF or SVG, whichever format you want, you can export it. So if I want to print it in a form of images, so I'll just go to an image export options. So there I can simply export it as a TIFF image, and it will get exported. So over here, I will have an options to provide in DPI. So DPI is will require a kind of on which display area or what is the size of page on which you want to print. According to DPI has to be selected. So higher a DPI means you'll get a better representations of your data sets. But the disadvantage is that if you increase the DPI, the corresponding file size will also increase. So higher DPI, in fact, you can use it, let's say generally in the A4 size paper, we go for 94, 96 DPI should be good enough. If you want to have a printing quality kind of scenarios, then in those cases, 300 DPI or 600 DPIs can be considered and so on. So once you give this DPI, the file will get saved. Like in this case, we are having a file available to us. And then what we can do is we can let me again export it. Export as image. Yes, this is desktop text. So this exported TIFF is available to us, and that whatever was there. So that the higher DPI is giving you a better representation of your maps. So this is just one way of exporting your data set which is which can be printed on a paper. So there are other options, like you can save it in form of maps. You can also put it as a scale. Different scales can be, a scale bar can be put in. And then you're also having a few additional attribute table if you want to. So there are different options which you can try out. Sometime you'd like to add few specific shape like symbols or logo of a specific company or organization. So those things can also be added. And then so these are the few options. Especially, in fact, you can also add it the grid or the layout, basically the neat line if you want to add. So all those additional annotations, you can add it onto this layout managers. And once you are happy with that representations, what you can do, you can simply export it in form of TIFF images. So with this, actually, I'll be ending this demonstrations. Now, if you have any questions regarding the demonstrations, then we will take those questions now.